can't work out. So I'm just confused. Oh, actually, we can test it.
Okay.
In this one, when you connect.
All right,
this
give me
to
1
this,
second.
You're getting what? 10 divided by 0.0. 1/8. So okay, no, it does. It doesn't make sense. That stinks. All right. Because this minus your 270. I think the mystery resistance offset is around 290. But it doesn't mean that they do connect. So yeah, so we can't do that. There's no other possibility. So we know that this isn't right. It has to be like this for one of the other combinations. But so that means we know that it's just it's the straight line. We can ignore the curve. So we just have one R here.
We'll get started in a bit.
Right?
That's different. But we still need, okay, and then
So-
still need
but
two resistors.
Can we do hers idea where it's like
I have an idea.
3 parallel?
If all three, no, but I think the problem, I thought about that, but if you have all three in parallel, you're
That was
just
my first
gonna
idea.
have one connection. Because then you have three in parallel here and you're not
You
gonna
can't
have a
connect
connection
them
here.
like with a wire or something like that? Connect to the line?
I don't think that's legal.
Oh.
I mean,
Okay.
no, because then you're getting into really big problems where, when you connect
Can we go
multiple,
like this?
to wait, to what?
So like have one here and then.
Oh, two there?
Yeah. Like have, like, and then split off there, and then,
That connects array. I mean, I guess that's possible.
but then my answer.
Which one is this, 15?
When I did it. The work.
Well, did you do it?
Yes, 15.
Well, no, okay. You
The
need to be getting the same current to these and to these.
and here as well.
Mm-hmm.
Right?
And our current.
And so these are pretty similar, so you
Yeah.
could, and actually, like, your voltage is lower here and you got a higher current. Right? Anyway, but if we say those are the same, the problem is they're actually off by,
Because a girl that was with us who studied, a dude had the same box as we did, but, he had a different one that was connected for some reason. But it was 3 resistors that he used.
okay.
I mean, in parallel, resistors in parallel.
Let me get you the sign.
The problem is that these aren't really close enough,
I see.
because, or which two resistances would it have to be? It would have to be from top right to this one and this one would be the same. And if you had this, but you have this one, which means that the connection from,
Our bottom two are the same.
Can it be from white to blue
Oh,
and
thank
blue to
you.
green? Because these are like 0.052, 0.05.
All right, whenever you're ready, just let me know and then we'll get started, all right?
Am I able? Oh.
So far, yeah, that's.
Should we leave?
Nah, you're good.
Yeah?
Unless, Tony,
Are we,
No.
yeah, no? If we're too loud, just tell us. Very cool.
it's fine by them, no
So
problem.
basically, this would have to be your connection, right?
It's fine by you, no problem.
So we'll move that.
All right, so, look through the homework. I'm pretty sure you started because it's due what, tomorrow?
Yes.
Yeah, so one of them is interactive, the B cylinders, and the other two are like standard exercises. Right, so don't worry about the interactive right now because you can just follow through on that. Just try the interactive, the standards, right? And then we'll go through that if you have any questions.
All right. I already got through the interactive one.
Yes, that's very simple. All right, I'll I'll be right
So
there.
it's saying current here,
Just two.
Did you understand what you guys doing in class today?
Yes, I took notes on a pre-lecture.
Yeah, that's the best way to do it. Just take that, because then all the equations that they give you in the pre-lecture, you can follow along in class and
you can just email
understand
the
the
teacher, be like, we
concept.
sent the
Did you understand the whiteboard? Did you guys do everything?
Okay.
If you understand the fair concept.
I don't know.
Email our TAs,
Did-
like,
I need to know what kind of possibilities. If these are the only two but the problem is it just says sample configuration.
yeah, you can have any kind of
So-
configuration.
I need to know how many possibilities are of this, because none of these just have a wire going off to them, right? Which is what we have here. So we exclude that possibility, which I feel like is fair. Then we either have, but then we run into the same problem, because, so we have this basically, which is what I have right here, right?
Yeah.
So you have, just this straight circuit. But then,
I'm gonna turn in the sheet. All combinations.
so, but and this would be great, but the problem is that R12, which we calculated right here, does not equal any of the resistances that we have here, and it should. Because if we connect our banana plug here and here, then one of these resistances we should get a number for, like get one of these.
At least one, I mean,
Because, because if they're in parallel, then it would give us one of these, or if they're not in parallel, then the other two have to be in parallel. And then one of these would have to be R1 or R2. So this can't be our setup, and if this can't be our setup, then I guess it has to be one of these. And if it's one of these, you might as well give up. I don't, because I don't know how you would prove that it's right.
but well, we get like 2 labs dropped, this will be my
Drop
lab.
I thought not.
Like, I'm gonna drop this one,
Yeah.
like,
No, I didn't do this class, but the minute I stepped out of the lab room, I didn't know what this. I'm not joking.
For physics too?
Like, even the TA stuff, just drop it. It is ridiculously hard, because there's literally infinite amount of combinations in fact.
Well, that's what I'm saying. If this would have worked
This is
out,
it.
that'd be great.
I'll write it, I'll like write her.
You
a
can
whole-
get possible combinations, but you don't know if it's right, because there's literally thousands more.
Okay. I'm gonna,
Because the way the numbers just work out, it's just, there's a lot. There's too many unless you
Oh,
like
yeah.
code it and no one wants to do that. And even if you code it, you're gonna get like a bajillion different numbers, so just,
I'll say I have advice from 2 TAs.
we're not TAs,
SIs.
SI, same,
they don't know what we are.
that's what they
Yeah.
call you TAs.
They
That's what
can't,
we're
they
calling
can't find
TAs.
us. Oh, well, yeah, fair enough.
You're technically
You still grade?
TAs.
No, we don't.
No, we don't grade anything.
We don't really do it.
I mean, like, I have access to my class, like, as a TA, but I don't go in and change grades or grade papers or anything.
Wait, we can?
That'd be fun. I'm joking.
Yeah, I had access last semester as a TA, this semester, because it's easy, because that way, like, the professor says, okay, this student needs help, I can go in and see what they're working on, right? And then same thing for like the flipped physics, as an instructor, I have full instructor
That
access.
I do too.
So I can go in and see, like, if Tony's working on it, I can go see what Tony's completed, what he hasn't completed. So like, in that regard, we have full access, but.
I just look at their answers to the check one questions and laugh, because 90% of this class just scrolls over it. Pretty good.
But, yeah, so
I don't really.
you can call us TA. How you doing, Tony?
I suggest.
Pretty good. I'm just trying to understand the homework problems.
Okay.
And I'm
Based
just
on the
gonna go
check
for
points.
it, and then I'm gonna
Okay,
draw.
well, if you need me to explain it, let me know.
Yeah.
If you think you're right, I don't wanna interrupt your
I'm gonna
process.
say like.
Actually, I do need your help.
Okay, alright, what's up?
Like, TAs, this is this.
No, I'm just trying to, I mean, I'm looking at the homework for magnetic field, and then I'm looking at the.
Is it the first one or the second?
First one.
Got you.
From, current in a wire?
For which? Oh, this one?
Okay, this is exactly like what we did in class, right?
Yeah.
All right, so let me draw this out.
Well, let's try working on the one that has.
Yeah,
Over here.
of course, yeah.
Right,
It actually gives you feedback if it not for
What's
that
up?
one, which is actually.
I'll just see, I'll give it to you later. Okay,
Yeah, sorry.
so this is just like what we did
I
in
wish I
class,
had
right?
been like
Where
this,
you
that
have
would be great, but
Right?
if you can have a single wire.
Shell, right?
Yes.
I'm just being honest, there's nothing you can do at that
But
point.
like, sometimes just use your exact
Shell.
words, we're screwed.
Out
Might
of
as
the
well,
page.
Yeah.
Right, so you have a current and a wire, right here. Just out of the page,
Yeah, like four.
I1. And then you have current in the shell going into the page, that's I2.
You gotta text everybody. No, the other one. The one that's using our lab data.
Right?
Oh, that's right.
So you have current going into the page,
He's got-
and then they give you I2, right? Now they say here is a point T
Does he live on campus?
directly along the x-axis. Right, so here are the x-axis.
Yeah.
Here's the axis.
Um,
Right, so this, the one that's going into the page
yeah.
is
I mean, one-
directly at the origin.
But, okay, so what is the length you can do?
Right, that's going, and then you have 2 points, 3 points.
So this should be.
You have point P here.
Distance.
Is that P or R? P, right?
And then we have the L.
Point P here.
Yes.
That just makes
Okay.
it L of each.
And the way it's shown in the diagram is shown that at the exact same level, right, let's call it a level. Right, at the exact same level, there's a point here, R.
Mhm.
Okay, and so that's P, that's R, like this, right? And along the line of R, there's a point S, right here. S right there, and that's the second one, right? So what is your question now? What do you need help understanding? Because we did the first, you did the first two in class all by yourself.
I'm just trying to figure out, I'm just on number 3.
Why is it possible?
Oh, number 3?
Yeah.
Is this the one you're messing up on?
Yeah.
Oh, Chris, what's up? It's number 3?
Oh, no, why is it possible?
Okay. Number 3. What is the y component of t located at this point? So this is point T.
Okay, looking at current in wire. So the
And now they're asking for the y component, so this, right?
So it's
Or
down
the
and-
downward component, we don't know, right? It's either up or down.
Yeah.
so it's like this
But
one.
now, so the thing to realize here is that t is inside the shell,
It's pushing in a positive
right?
direction.
T is inside the shell. So then we know that, like you said in class, we have to create something around the shell inside here at this to find the density of T. So because we're not taking the full charge of the shell, we're just taking this small half, right? So here is the equation. So we go back to the basic equation we had.
You're looking at BC.
Yeah.
Where the equation that we're given is integral of b
So,
dot dl,
L plus.
right?
Mhm.
B dot dl.
Nice. Well done.
And you know that you need the y component, right? So you get b y of t,
This is just L divided by 2.
okay, times 2 pi, okay? Times
Is that
pi.
versus 0? It's going to be, oh, which direction is it in?
well, I1 is pushing it.
Yeah.
2 pi x of r t.
Oh, sorry.
Okay.
So this is 2 pi x, meaning that I think
So
the
it has to be along the
distance,
negative.
Okay.
It's pushing.
right?
What is
Because
the magnitude?
you're doing b
Look at this formula.
times dl, right?
Oh, yeah.
and it's directly along the x-axis.
Mhm.
Right.
Because.
Then you have mu. You know what B is mu naught I, right? B equals mu naught I, and I is the I enclosed. So B
But you can have 2L, and then you can have 2L plus W.
enclosed.
So you can't just say
Mu
it's twice
naught
as big, because 2L plus W is
I-
not twice as big as L plus W.
enclosed.
Does that make sense?
Mu naught is a constant, so we don't have
It's
to worry
kinda
about that.
skipping
All right.
steps, but.
So we
you
get
have
then
to do calculations.
mu naught.
So 2L plus
So
W.
to find
is
I
just
enclosed,
force
you have to take what he said
from
about the
AB.
ratios
That's the
of
distance.
the inner area and the outer area,
Mhm.
right? So you have to take the ratio
Yeah,
of this
And then-
blue half
2L is just the distance.
over the ratio of the whole thing,
You are to DC.
Right.
correct?
And so you're gonna have to do.
So
both of
let me
those.
go back up.
This one's gonna be pushing that, and that.
Take the ratio
Because if it's
of the blue half,
Right,
okay?
right.
So if you
And
take the ratio of the
magnitude,
area,
so you need to find the
of the
net
blue,
force that's
that
pushing
blue-
squared that way to the wire ones. And then you need to equal it that with the net force for wire two pushing
of
those
the-
ones.
So solve. for
oh, this passes T,
this
right?
using
If you take the area, the ratio of the
solve for it
areas
again using
would be the area of all of this
Solve for it.
Mhm.
using
divided by the
AB
area of
and
all of
BC,
this,
Because
correct?
one of them is
That'll
gonna
give
be-
you the charge
so
density.
BC is gonna be
that's
pushed,
just
and
enclosed
AC
within
the
this.
AB is gonna be
Okay.
pulled.
Does that make sense? Remember a while back, we did like something where you
This
had something
one.
like this? So then you did,
So I'm
this-
adding
this, area minus this area to find out the charge
Right.
here.
net.
We did it
And one
for
of
like
them's gonna be
conducting,
possible.
shells and stuff.
Mhm.
Conducting cylindrical spheres,
But you
things like that.
Right.
Right? So you take the ratio of the two areas, and so then you get this. Mu naught comes out, and then you get I
So you can
enclosed
just subtract one.
is this I1, which is inside,
Mhm.
right?
You can do the
Which
same
is, this is
for-
A,
for the net from the wire.
and this was B, right? And you guys have the thing in front of you. So I1 is coming out of the page that's inside A, right? So it's I1 minus whatever this is. So it's I1 minus pi and R squared. So it's x of t minus A squared. I think I ran out of room. Alright, let's go down. Oh, okay, well, if I run out of space, we'll redo it. Over.
I have a lot of trouble with the internet spans with words
Okay, good space. So the pi's will cancel out, right?
Mhm.
You got all this. Alright, so the pi's will cancel out, right, because you're just taking the ratio of areas. Now this is x squared of t, which is this boundary minus a squared, right? So that will give us this. And this is b squared minus a squared, will give us this. Right, so then you're essentially finding what's left inside here,
60% sure.
right? So you can simplify this out, or you can just plug your numbers right in. Make sure you keep your units the same, because all the units are given in centimeters. So you want to convert to meters.
I understand.
And I think we're given milliamps. Are you given milliamps? You want to convert to amps. Oh no, you're given amps, so you don't have to worry about that. And then mu naught is just a constant.
All right. The constant, which is,
Uh,
oh, my,
You might have it in, I think it's like 8, 10 to the negative 5 or something. What do you know what mu naught is?
It's just 4 pi.
12 pi?
4.
4 pi is mu naught? Really?
Times times.
Oh, yeah. Okay, mu naught was this. Was it 2 times 10 to the negative 7, right? Is that what he gave you in class today?
Yes.
That's the simplified version.
Okay, so just use that then. If it's the same thing.
Thanks. Okay.
Alright, so the first two should be fairly easy because we did it in class today.
Mhm.
Alright, and it's very straightforward, just follow the same equation.
Okay.
Okay, so try number 4. Is there 4 on this? Yeah. So it's the same. Do number 4. I'll give you about like 5 minutes. It's like, that's good. It's really simple. Shouldn't take longer than that. Just think back to what we did in class for number 2, and that should help you solve number 4. I'll give you 5 minutes, and after that, if you have questions, I'll go over it. But it's very straightforward. Like, just don't even. It's just think through logically of what you did in number 2, and the answer should come to you.
Okay.
Yeah, don't mind me. I got two exams tomorrow, so I can't study for it.
Good luck.
Yeah, thanks.
Yeah.
Let me,
Don't worry, I do homework and career services all the time.
don't. No, I mean I'm here for you guys, but like I want to before doing. It's just very simple. It's not even that complicated. Number 4, it's just very simple. So I want to give you guys a shot, and then I'll explain it. You guys get it? What's the answer?
Just with the negative first.
Tony, working on it, or did you get it?
Working on it.
All right, give me 1 more minute. And then Christopher, in 1 minute, come up and explain how you got it. Because it's fairly simple. I'm gonna try to make the sessions more interactive. Even yesterday, were you here? Yeah, you were here yesterday. So I was trying to get people to come up, and I realize, and from personal experience, it's easier to understand when you teach others, and it like helps you with your own understanding. So,
Straight line.
all right, come on up. Erase. Yeah, you don't need any of this. Tony, did you write this down?
Yes.
Yes. All right. Okay, Christopher. Why don't you go ahead and explain? You did number 4. All right. All right, Tony.
So basically, I guess. So, you have to do the first part, right? That's number 2.
Mhm.
So it's e times 2 pi r over 8, because if this is a full circle, this is 1 over 8 of it. That's 1 over 8 of a circle of radius. It's
.31, I think.
minus 0.38.
Everyone has different.
Okay, so it would just be 2 pi r over 8, which simplifies to b pi r 4. Yes?
Mhm.
Yeah. So if you're going, that's if you integrate from here to here. But if you go from here to here, it's the same 2 endpoints. So the answer would be the same, but it would be negative because you're going from here
Mhm.
to here.
Mhm.
So you just get a negative of which one.
Okay.
That's the answer.
All right. That makes sense.
Yes.
All right. So it's basically what you did in number 2, but now you realize that instead of going from P to R, right, which is essentially the same as going from P to S, S to P. So instead of positive, you get negative.
So it's a negative value of what I got from number 2.
Right. But do you understand why though?
Because you're going from P to S. Well, to get back. No, because you're going from sort of point P to point S to point P, so you're going downwards, right?
Right. So initially you were going in this direction. Now you're going the opposite. Right.
Uh-huh.
So whenever you go in the opposite direction, essentially, like compared to what you were doing originally, then it'd be negative.
Mhm.
Okay. All right. That's good. So is there a number 5 for this one? Okay, number 5. Suppose the magnitude of a current I2 is now doubled. How does the magnitude at 2.85x, 0y change? 2.85. Okay, this one is also very easy. So remember back to Gaussian surface that will help you with this problem.
Mhm.
Try number 5. It's very simple. I'll give you 2 minutes. Okay?
Okay.
Or how long do you want? Let's give you 5 minutes and then we'll go to 2 if you guys solve it. Okay, it's very simple. It's not that bad. And then we'll move on to homework 2. There's no number 6. Yeah, it's number 6. It's some notes, but we can do that. Try number 5. Very simple. You guys get it?
Yes.
Okay. Tony, what's the answer?
I said it increases
Okay. Why did you think so?
because when I looked at the equation, which
Well, so don't look at first determine where your point is,
the point.
right? So it gives you a point, right? It gives you the field at whatever number you have, comma 0.
Right.
So you know it's directly along the x-axis,
Mhm.
and it's some distance away from this origin. So come up here, okay, and given your A, what's your A? What A did they give you?
A
Yeah.
2.55
Okay, and what B do they give you?
0.
Oh. What?
E.
A and B, here and here.
Oh, you mean, no, okay, take it, no, it's not 2.55, it's 5.1 centimeters.
Okay, what's A?
5.1,
All right, what's B?
7.30.
Okay, and let's call it point C as your new point. What's the origin, what's the coordinate of your new point?
2.550.
Right, okay, so come up here and draw out where your new point is. Oh, kind of wrong. Did you send the thing first? No. You just use this one there. So draw out where your new point would be. Yeah, somewhere around there, right? On the inside.
Right.
Okay, so now remember when we did Gauss surfaces?
Mhm.
We said whenever you're looking at a point,
Mhm.
everything on the inside reduces to a single point. You don't have to worry about everything on the outside.
Mhm.
So for this one, draw your Gaussian surface on point C. This is like what we did for Gauss.
Gaussian surface.
Right. Draw your Gaussian surface around point C. Around point C. Okay, so Gaussian surface is around that point. Don't worry about it, it's cool. So Gaussian surface is when you're considering a point.
Uh-huh.
I got it. When you're considering a point, right, you want to find out all of the charge on the inside. Okay? So suppose you have like this charge C.
Mhm.
When you draw a Gaussian surface, it means that basically what you do is you draw a circle around the entire region with the same distance. So at any given point, the radius from here to here will be the same as from here to here.
Okay,
Okay, that's a Gaussian surface.
okay.
Let's label that GS. Gaussian surface, right? We had to use these for our other homework problems where we had a point out here, let's say point G, okay? And we want to say, okay, what's the force acting upon point G from all of the currents? Remember when we had point charges, we had like +5 and -10, right? So let's say this was +5 and -10. We draw a Gaussian surface over here and encompass all of the points inside that surface. So same thing we're doing over here at C is we're encompassing all the charge inside that surface, right?
Mhm.
So if you have this surface, the only current that's inside is I1,
Mhm.
right? So the question asks, the magnitude of I2 is doubled. So now what's the field on C? But I2 is outside of our surface.
Mhm.
So it doesn't matter if it's doubled or cut in half or tripled, because all that matters is what I1 is.
Okay,
So now, what would the answer be?
the same.
It would be the same. So go back and change your answer.
Okay,
I'm going to erase this.
all right.
But you understand how we got there, right? It's like you have
Yes.
to draw, you have to first find out where your point is, and then you have to draw a surface around your point. You have to isolate your point and reduce everything on the inside to a single point or a single current or a single charge.
Mhm.
And all that we had inside was I1.
Mhm.
So we didn't have to worry what happened to I2 because it's not inside, it's not affecting our point.
Mhm.
Okay, so did you guys start on the second one or no?
No. This looks, oh boy. Oh, is it the slab?
No, these are sheets, not slabs.
Hey, I hate slabs.
I know. Okay, try number one. That's very fairly simple. I'll give you about 3 minutes till 7:45 to do that. And then within 15 minutes, I'll do some of the other problems, right? But yeah, so I'll give you about 3 minutes to do that one. I want you guys now, I'm gonna start, instead of just giving you the answers to the homeworks, I'm gonna kind of do what we did today, is where you guys try to solve it, right, and then you teach it to others, and then if you guys can't absolutely do it, then I'll come in. So I want you guys to try. I know it's kind of hard with other classes to do the homework before coming to sessions, especially because homework was just due yesterday, and today's Wednesday, and it's due Friday. So that's fine, the Wednesday homework is fine. But the ones that we did in class, because every whiteboard problem is one of the homework problems at least, so at least try to do those, because that will take 10 minutes, because you already did it in class, right? So you know the process, you understand it. And then in class, and then in session, I'll explain the process. So for that. So try that. Yeah, I'll give you 2 minutes. It's very, very simple, very simple. Did you get it?
No.
Chris? Chris? Yes, no, maybe so?
No.
You didn't get it? Oh,
I'm
come
trying
on.
for the equation for, sheets.
You guys don't even need equations for this one.
We don't.
No,
First
no.
one. Second one, I don't think you need equations.
You don't even need equations for the first one. Do it again, try it, now that you know you don't need equations.
Oh.
Did it click, Tony?
Not
Not yet?
yet.
Alright, we'll get there. Chris, did you get it?
Yeah.
Okay, come up here and explain. I'll draw it up for you while you come up. First one is out of the boards, into the board. P, R, P. Alright, come on up and explain. I'll cut you some slack on this one because it's due Friday, but this problem is very simple. Alright. Alright, go ahead. Use green for the other one. Okay, so explain what you did.
So find the,
Explain to Tony.
oh, sorry. You find the field at this point due to both wires, and they both point in the negative y direction, so there's no x component, only a y component.
Okay.
Alright, so you're very right, Chris is right. Thank you. So remember he said in class, when you have multiple wires right next to each other, it becomes an infinite sheet.
Mhm.
But we can treat the current to be in the same way as if this was one charge
Mhm.
and one current, right?
Yes.
So when you do a cross, okay, you're going into the field, into the board, and you're coming down.
Mhm.
So at this point, your field goes directly down, correct? So for you, if you would cross, you'd go up, but you remember it's always opposite because you're left-handed. So for you, it'd be going down.
Mhm.
And so over here, if you're right-handed, it's coming out, and you cross all the way, it goes down.
Okay.
For you, it's coming out, you cross all the way, it goes up, but again, opposite, right? So it'd be going down.
Okay.
So the field, the force from both fields is only in the y direction. There's absolutely nothing in the x direction.
So that means it's 0.
Go. You don't need equations, you don't need anything.
So anything that's no equation-ish is 0.
No. Sometimes the equation might give you 0, but in this case, you just have to think about it logically, saying you draw the field, they're both going in the same direction.
Mhm.
And they're both going in the y direction, so you know that x is absolutely 0.
Okay.
Okay, so the first question is very easy. What's the x component be 0? So if I ask you what's the x component of point R and point S, what would that be?
0.
0, right? But they're not gonna keep asking you the same question. But anyway.
I wish they did.
Okay, so now what is the y component at point P. So you know that you have the current density of what, 19? I have 19 wires. You guys can have different ones. So you do, for that one, right, you would find the Y component. You know that they're both Y's,
Mhm.
and they're both negative, so you'll have a negative, right? And the equation is what? What equations do you guys know to do things like these? It should be from class. It probably gave it to you in class. Check your notes.
B equals U naught I over 2 pi A squared.
Okay, that's fine, but do you have an area in this?
Yes.
How?
Well,
You don't have an area.
no area.
No area. So, what was the equation again? What did you say?
Me, I said it was, okay, I might be wrong, but I said it was U naught I over 2 pi A squared times R.
Mm-mm. You don't have an area or R, right? I mean, you have R, but you don't have an area, right? So, you know that equation is not good.
So it's gonna be, I found another one, says U naught I over 2 pi R.
Yeah.
Would that click?
Okay, so mu naught I over 2 pi R.
Mhm.
So you don't have area, you know mu naught, you have pi, you have R, right, of your radius. So it's negative mu naught, and this is negative because remember, it's both are going in the negative y direction.
I understand.
Mu naught over 2 pi.
Bless you.
Thank you. Negative 1/2 mu naught pi. Now you have I, right? But you don't know, you have a wire, you have a sheet now, right? So you need the wire density times the current, correct? So your wire density is given by N, whatever N is, and then you just add up the two currents, right?
Okay.
So it's just I1 plus I2.
All right, I'm looking at the infinite sheet of current, the B equals 1/2 U naught and
Pi N.
Y pi N.
Okay, so you have, this is just your B.
Okay.
This will give you everything, all this stuff, right? Will give you everything you need to find out the stuff from the sheets, meaning what's the total. Now remember, it's not just one current, right? It's not just one wire. So you can't just take one amplitude or amps. Yeah, you can't just take one current, right? You need the current across everything.
Mhm.
So they give you the current, the density, meaning so many number of wires are packed within this certain number, like this certain area or a certain length. You have to multiply that in order to find the total current of
All right.
the sheet. That makes sense.
Yes.
So over here, you just have one X. But if you have like 40 different ones, all in this just one spot, right? You have to do 40 times whatever the current is.
Mhm.
And here you have N, which is, everyone has different numbers, but you have I1, I2, and you know that N is the same for both.
Is this I1 plus I2 or I1 times I2?
Plus, the thing plays horribly.
All right.
But just think about that intuitively as well, right?
Yes.
If you have Ni1 plus Ni2, you can just factor out the N. Right.
Okay.
okay? And n is the same for both sheets.
Mhm.
Okay, so that's how you would approach that. And remember, you're using infinite sheets. So your equations will be different. Every time you're trying to find an equation, just think, what do I have given to me? And what equation requires those variables? So you know that you have a charge density, so you look through your equation and say, okay, this equation uses charge density. So maybe this might work. You know, if you're not given an area, don't go to an equation with area in it, because that's kind of pointless. So same thing for number 3, for point R, right? Over here, let me just go through this last one really quickly before session ends. So over here, you have both of these currents acting upon it, correct?
Mhm.
So now over here, you have an addition of over here, you have an addition of both the currents, correct? Because they're both going in the same direction.
Mhm.
Over here, what you'll have is, oh, into the board. Remember, this is red, and this one is green.
Mhm.
Okay? So for this one, you're going into the board, you curl up. This will be going up. But remember, infinite, the B field is infinite, right? It'll reach across all states. So this B field will also reach point R. And it goes down, right? Because if you cross, down. So it's I1 minus I2,
Okay.
right? And then you just use the same equation, but here you do minus.
Okay. I calculated like that and I got it wrong.
Using this?
The unit, because, well, I know I1 has to be negative because it says in the negative z direction. Right?
Okay, what error is it giving you?
It doesn't say anything, it just says my value is wrong.
Okay, so walk me through what you did.
Okay, so, well, I know that I know that the only thing it's, well, I convert one of the values to meters and kind of,
The 19 wires per centimeter to meter?
yes,
Is that what you converted?
yes.
Okay, so what did your answer come out to?
Well, so I converted that to meters and I got, well, in my case, 1,600 wires per meter.
1,600 wires. 1,600? Oh, because you have 16. Your density is 16?
Yeah.
Oh, that makes sense. I'm looking at 19. I was like, how did you get? Okay, yeah, that's about per centimeter, 1 centimeter. No. Whoa. You have 16 wires per centimeter. 1 centimeter is 100 meters. You divide.
Damn it.
Don't try not to do these type of things in your head. Try to do them on paper so you can see the units canceling out, and then you get left with 16 over 100 wires per meter. Right? So then once you do it on paper, it will help you see, like visualize what happens to your units.
Okay,
Okay?
I understand.
Always write it out. That always helps.
When in doubt, so always write it out for everything.
Yeah, because if you can visually see your units canceling out, that's going to make a big difference. Okay, so I'm going to stop recording. Because that's the end of that.